Hello and welcome. It's been frankly a bit too long, and I feel like I've had to come in and share my knowledge a little bit. And what I want to do in this video is I want to explain polling versus event-based weighting. So what are they? Well, polling, and you've probably done this many times without even noticing it, but you basically have a loop that checks a condition and it keeps checking that condition until it's met. An event-based the other approach, it only checks when you need to. So it only checks if that condition changes or that value changes. And so let's look at some code so you get a better feel of what an example looks like. So polling, our first example, is we want to check, in this example specifically, we want to check if the player has a tool on them. And so we do a loop. We get each uh, child of the character and we check if it's a tool. And if it is, we print, yay, we got our events or our polling triggered, and then we escape. Now, as you see, since we're using test.wait, this runs almost pretty much every heartbeat, meaning if your game is running at 60 frames per second, this is going to run 60 times in that second. And we have this running for a minute, it's going to run 3,600 times just to check this one simple condition. And this is looping through all the parts in the character, so you can assume how much this stacks, especially if you have a game where you have a bunch of accessories, for example. Now let's look at the events-based approach. In the event-based approach, we only check if a child is added. And if that child is not the tool, we stop. But if it is, it continues and it triggers our events and it disconnects itself so it doesn't keep running again. And you can already tell how this looks a lot cleaner, but also it's much more efficient. You only run it, it only runs when it needs to. And for the polling one, you kind of waste CPU cycles, and instead of doing something uh, your other game requires, it's stuck kind of checking this condition. So let's test and see how it compares. So I have this sword here. I kind of went all out on this. I made a cool little brick platform. But if we pick up this sword, you see both of them run. And guess what? The event one runs faster. So not only is it more efficient, but it also runs at kind of like the fastest it could ever run. See, this one checks every 1/60th. This one checks almost instantly when it happens because when that sword is picked up, it will fire that event and then run whatever other stuff it needs to run. So let's look at an example now that we've seen like how this event based and this polling compares. Let's try it and make our own. We ran into a sort of technical difficulty, but as I was saying, we have uh, a detector that sets when they click it, you set an attribute to the player or the attribute to the character to true. And then in our example here, we have a sort of loop that checks if that attribute is there, and if it's not, then it will wait. Now let's see if it works. Let's go to our output. Let's click on the brick. Yo, it works. Okay, that's cool. Now, however, let's check the sort of performance we have on this. So if we go to performance and we go to script performance, I have to reload this. You see these two, attribute weight and polling. You see I'm not doing anything and they're running 60 times per second. They're checking right now if that attribute is true or if I'm holding the sword. And sometimes even you have the first example, the activity kind of rises up, and that's because it's checking. It has to check every single part of my character, and uh, since I have R15, it has to check all these parts. Imagine it has to check every single one of these 60 times a second. Yeah, that's a lot of work. So let's see how we can sort of fix our attributes script. And this is actually a really easy fix. You uh, can kind of sort of implement it into your code right now, and that's just using the events, which is on the that Roblox provides, which is called attribute, yeah, get attribute signal, attribute change signal, and then we put in our attribute we want to change, or that's changing, I guess. And if it's just flipping between two values, so in our case it's just true or false, we don't have to connect and check uh, if that value is equal to something specific. We already know what that value will equal to when it changes, so we can just wait. And we only want to wait if that attribute is uh, not already not already there. So if that sort of attribute is not enabled, then we just wait here. A quick editor's notes is I forgot to make this an if for this specific example, but let's say it's an attribute that checks how many times you clicked it. So it's a counter. It's a number. Well, in this case, you can do a while loop, and also in this case, you can check if that condition you want to be met is true. So while if you want for it to wait until it's equal 5, for example, you could do not equals 5. So each time it's not equal 5, it's going to wait again until that value changes, and then it'll check again if that value is equal to that. If not, it'll wait. And this is, again, more efficient than just doing a regular test await. And if we go back to our script, let's go to our output and let's click on it. It works just fine. And if we go to, what is it, here, and script performance, you see it doesn't even show up anymore. It doesn't have to run uh, 60 frames a second. It only has to run when it needs to, and that's what we want. Or actually, that's because I right-clicked it, but I can show it again. You see, it doesn't even show up. And now, if you're asking, well, what if I don't? What if I'm making my own module and I can't use a Roblox event for me? What if I have to make my own? What do I do? And that's where I have this example. So in this example, I have a stun module, and let's just go over it so you're comfortable with it. So we first have initializing function. This function will create a thread that will loop each time. It will loop through all the elements in this table that we kind of like tag to the character. And if one of those times is below our current time, which basically means like it's expired, then we remove it. And then we use a check to anchor the root parts. And that check is just checking if we have like any sort of more values in our table. And then to add a stun, we just add a value to the table that we have, and we add the time we want, and then the current time we have. And then of course we have our classic example of polling where we sort of wait each frame to check if they're stun. And if I have a sample script right here. We initialize the character, we add the stun, we wait to stun, and we have all this. And if I enable this real quick and run it, we can see I'm doing fine. I think at one point I'll get stunned. Yes, I'm stunned, and then I'll become unstunned. Awesome. So the script works fine, but we can do better. And this will, and even if it might not look, it'll definitely show you like that you know what you're doing in the sense that, oh yeah, I don't want to pull, I want to do an event approach. So really the first thing that I see looking at this is that we really don't even need an if statement here. Since the is done already returns a boolean and the anchored is already a boolean, then we can sort of just like swap these here. So already that shortens it. If they're stunned, it's true and we want them to anchor. Okay, that logic works. And now let's tackle this loop right here. So you almost always know when a value will change. Almost always. There are very few times where you don't, but especially when you have a module like this. Right here in add stun, we know what this value is. This value is time plus time amount. Okay? And if we know what the value is, we most almost certainly can write an event-based approach for this. So in this example, instead of checking every frame, like if the stun time is or if the time catches up to the expire time or whatever, we can just check and let's say whatever seconds they give us, and then delete it then. So um, we can sort of write a thread because obviously when we add a stun, we want our code after it to run. So we can add a delay for the time amount, and then in this delay, we can remove this value from the table. And how do we do that? How do we remove this value from the table? Well, we can check again like we do here, or we can um, add an index to this. But if we add an index, uh, sometimes the values will shift because we're inserting it. So, and if we're deleting it, it might like shift it back and stuff. So, quick editor's notes. I realized that you can in fact still do this. You just can't use the uh, table.remove because table.remove will in fact shift the elements. But you know, I think the insert, no, it doesn't return anything. So, what you're kind of forced to do if you really want to make it like as secure as possible is in instead of sort of doing table.insert, we can just uh, get the length of the table, add one to it, and then just add our time. That's basically the same thing that table.insert is doing, but the reason we don't use this anymore is because we're doing two operations. We're checking the length and we're adding one. But the way Lua or Luo or whatever you say it is written, table.insert is just one sort of operation, and it's kind of optimized in a way where this table.insert is actually faster. So that's a quick uh, knowledge. I mean, negative knowledge. But after you have this, we sort of already know what index it's gonna be at. The index is gonna be at the length of the table plus one. And when we remove it, which I'll explain later how we can find a way to do it, is instead of using table.remove, because table.remove will shift, as I told you, we can just remove it like this. We can just make it no. And sometimes, because we do this, it won't shift and it will create gaps in our table. And that's still fine for this. The hashtag, or I mean the length operator, it will check until it reaches no. So this will work fine. But when we loop through it, it's gonna also think it's gonna skip over the values that are nil and beyond. So for example, we have 3, 2, 3, nil, and a 1 again. So it made like a gap here. It won't if we loop through it regularly, like I think I had some time like this. And if we loop through it like this, it's gonna think this is an array and it's gonna stop right here at nil. So to bypass this and to also account for this value, we have to use pairs. And that's kind of like a iffy thing, but that's sort of the only thing that came across in mind to sort of fix that issue. But yeah, uh, may the video continue. I realized right after that we also don't really need to loop here if we just save the sort of length or the sort of amount of elements that are already in there. So if we have, later on I'm going to add the stun time thing, but if we add another one that's like elements or size of stun time table or whatever, we can sort of add one each time we make a value like this. So for example, in the affected, we would have something like stun time size, and we would add one to it, and then when we make it nil, we just do -1. And the reason we want to know the size is because when that size is 0, we know they are no longer stun. So instead of doing the sort of what is it, that the hashtag or length operator, we can just check the stun time size directly. So we just check it we just check if this is equal to or not equal to 0. And yeah, so it'll be weird, but instead of checking every frame, we can just check right here when it's about to expire. And just for assurance, we can add 1/60th of a frame. And this looks weird, but we kind of know that it'll work. So yeah, so that's good. And now we just have this. So we stun. We still have to check every frame to see if they're stunned or see if they're not. Now we can fix this too, believe it or not, and that's because right here we know when a value will be removed and we know when a value will be added. So let's just check then. Let's add a checker right now. Let's create a function, uh, anchor uh, character, I guess. We'll have a character as our parameter, and we'll just put this right here, just so we don't repeat ourselves. And then what we can do, actually we know there'll be anchor right here. We can anchor to true right here, but just for consistency, we'll have our function instead. And then when it removes, we'll just check again. Isn't that awesome? We removed the loop entirely. We don't even need this. Okay, now for the other loop right here, you might be saying, okay, how would I add this weights, for example, the one we have in our example problem? How should we do that? And this is where the coroutine library comes into play. And this, yeah, no, there's some pros and cons to this. If you don't know which one to choose, just uh, test it out and see which one works. Because sometimes the condition is sort of negligible. You don't even have to worry. Sometimes you might be waiting so much, or you might be using this so much, where it would definitely be a pro to add some sort of event approach. So what we can do is that luckily the coroutine library gives us a function to yield. And this, instead of wasting CPU cycles, this will just stop our running thread, so our script, for example, until it resumes again, which we can resume it when the condition is met. So that's awesome. But how do we know what thread to resume? Well, we can resume first, to get the thread we're currently running. We use coroutine dot I think running, yeah, coroutine dot running. And then what we can do is we can save this. This gives us a value. It's, I think they call it thread. What did they call it? Yeah, they just call it thread. So this gives us a value which we can save to our table we made that's tagged with the player. So really, this should have two spots, one for threads, or I guess yields, yeah, you can really choose whatever, but I'll use threads. And then we have one where we have the actual times, so stun times. And then we just have to do some bit of morphing. So this is stun times right here. This is stun times. This is stun times. And what else? That's pretty. I think that's all we have, right? Yeah. And actually, since this is a table, you can make this into a variable without worrying about it not copying out, because it'll save the reference to the table instead. So we can indeed just store this into a variable since we already used it multiple times. So we'll just call it sometimes of char, and then we can just substitute this instead. It'll make our code look nicer. Or we can just call it we can say the value some time table. There we go. Okay, So we have that, and let's add our thread into here. And the reason I have a table instead of just a value is because what if, for example, we don't have just one script waiting until it's unstunned. Let's say we have like three other scripts or five other scripts. You know, we sort of want to keep track of how many of these are waiting to be run again. So we insert the running thread into our affected uh, character thread table, and then now this is sick. This is sick right here. We don't even need this loop right here. The loop is substituted for the yield, and for it to break or for it to keep running, we just have to resume it. Now, when do we resume it? We resume it when the player is unstunned. How do we know that? Well, we know because we're removing the value right here and we're checking again right here. So right here where it removes, you can also sort of write a function for this. Let's do run yielded unstunned threads. And you know this, depending, you might have like 5 events for this. You might want to use a more specific name, but I'll just have this for example. And first, we have to check if we actually can uh, run the yields because remember we're checking the condition if they're unstunned. So let's really check if they're stunned. So is stunned. If they are stunned, we don't want to do anything. But if they aren't, then we loop through all the threads and we run them or we resume them. So let's loop through all of them. And this should be in our affected table and in threads. We loop through it and look, oh, the autocomplete already did it for me. But in the coroutine library, there is a function called resume. You resume the thread, and everyone's happy. This code will now work fine. You see how we reduce the code. We remove the loop entirely. There's absolutely zero loops. We have we we yield the thread and we resume when we need to. When do we resume? We resume when it is unstunned because this variable is known. We know when it will change. If you know when it will change, you can almost 100% use this method. So let's even check if it works. Small mistake, and that's because in my is stunned function, I forgot that since we modified this table, we also have to modify this to check the stun times specifically. So let's run this. I realized I made another mistake, and that mistake was that I made the function right here, but I didn't quite call it, which should have been done right here. So yeah, that should be it. Let's run it to see the fruits of our labor. So I should be stunned any second right now. I got stunned, and I should be unstunned. And it prints unstunned. So this works, the add stun works, the initializing works. And actually, for the initializing, you see this might be kind of weird how I have to initialize it here. You shouldn't really need to do this. And that can be fixed. Usually in games you have a folder with all the things that have humanoids called alive. For this case, I only want players to be affected. So what I can do is inside the module, uh, since I'm only gonna use server stuff here, the client, I don't think the client should really handle if they get stunned or unstunned. This is fine because all this code that isn't functions will only get run once if you require the module. So right here, it's fine if I put an event. So on player added, I guess for neat's sake, I'll make a function for this so I can just connect to it. And then since I want the character specifically, I guess I'll add another function for this, which I can just connect. Whoops. And right here, I can just sort of initialize. And because this is an event, this should run quicker than this, I believe. But well, all right. Well, that should be it. I might make another video going over how we can actually make our own events, not using a module like fast signal or lemon signal. Although those are cool, you can use those. I want to see how you can make your own vanilla implementation, so you understand sort of the details that go behind making those sort of events. But this is just one of the many functions that events have, and I'd say this is a pretty useful one. And yeah, I hope you learned something new. Hopefully, you sort of are conscious of the decisions you make when using polling, and know there are also better alternatives that use less CPU cycles and check uh, conditions less time, especially if those conditions are expensive. You really want to look into how you can sort of make it sort of event based. So yeah, that should be all. Thank you guys for watching. I'll see you in the next one.